This stream is sponsored by Brilliant.
We have liftoff. Propulsion continues to be nominal.
Our pressure looks good.
Doubling up. Roger and roll, Atlantis.
Water towers can fly! Yes!
Tango down to nominal.
Flight outside SC off. Bring in SC off. Off.
Yikes. You bet. Concur. We don't need any more of these.
Good afternoon, everybody, and welcome to Cape Canaveral, Florida, where we're bringing you live coverage of the Transporter-5 launch on board SpaceX's Falcon 9. I'm Ian Atkinson. I'll be your host for this afternoon's webcast. I'm a writer, live stream voice, jack of all trades, kind of. But I'm also joined by my good friends, Alex, one of our resident Falcon 9 experts. How you doing, Alex?
I'm doing great. Let's see some action today with a booster launch and landing. Back on land.
Awesome. Yeah, I'm very excited. It's going to be a return to launch site landing, but we'll get into that later. And I'm also joined by one of our Boca Chica photographers, Nick and Sweeney, making a live stream appearance. How you doing, Nick?
Hi, Ian. I'm doing great. How are you?
I am doing great. Very exciting to see, again, like I said, a return to launch site landing, a very rare occurrence these days. So we'll be bringing you live coverage of the Transporter-5 mission, answering your questions, having a nice, fun conversational live stream here. Alex, can you start us off? What exactly are we looking at here? What are the transporter missions, and what is Transporter-5 doing?
Yeah, so the transporter missions are SpaceX's response to the large, a surge in small satellites in the industry, and basically they're launching a rideshare mission with 59 satellites in this particular mission, but we have had other missions like with way over 100 satellites on them. And they basically offer ride shares to low Earth orbit for very, very economical price tags, let's say. So it's sort of like competition / not competition to Rocket Lab, Virgin Orbit, all of these small satellite launchers, that are launching these satellites, but on their own, just not ride share missions, or maybe only a couple of them at a time. And they're launching these regularly, so that's sort of why it is sort of like the small satellite rideshare mission program, where in 2021 they were launching like once every 6 months, and now this year they are launching once every quarter, every 3 months, sort of like that. And we have had one launch this year in January, another one in April, and this is the third one this year. And then we'll have another one in October, Transporter-6. And in this particular mission, we have also the debut of some new tugs. We might talk about that a little bit later in the broadcast. But yeah, it's really exciting to me that we're seeing all of these development of not only just launching rideshares, like a bunch of satellites all clubbed together in the same dispenser, but also in that same dispenser are ways for the satellites to reach their final orbit via the use of space tugs, which I think is really important, especially when we look at Starship.
Yeah, absolutely. And space tugs, like you. Oh, so go ahead, Nick.
Yeah, these transporter missions are always really exciting to watch because you're seeing what the goal has been for so many years of SpaceX to bring the cost of reaching orbit down so much.
Yeah, absolutely. And like you said, Alex, like space tugs on these missions are very important because the Falcon 9 second stage has already proven itself to be, a very what's the word I'm looking for? Very accurate in orbital injection. But you can't get all of these. Oh, and
yeah,
we
there's
just had
been
a
a hold
hold
in
in the
count.
countdown.
Yeah, it looks like we have a 30-minute hold to allow time for additional thermal testing of the payload deployer. That's rockets for you. We get all excited, and then there's a 30-minute hold, which is really a good thing because it means that they caught an issue and they're taking their time to take a look at it and make sure it's all good before we light the fuse.
Absolutely, well said, Nick. And yeah, they want to make sure that everything is going well because, in spaceflight, I think Elon Musk has said it several times, there are thousands, if not millions, of ways that things can go wrong, but only one way that things can go right. So you need to make sure everything's in line here, whether it be an issue with the rocket, issue with the payload. You want to make sure everything's going well. And especially when you have a mission like this with 59 payloads on board, there's a lot of things to juggle here.
Yeah,
but like we were
indeed.
discussing before, sorry, go ahead, Alex.
Yeah, I was agreeing totally with that. It takes a little bit of a time to actually go through everything and make sure that these customer missions are not like Starlink missions, right? You got to make sure that all of this is going right.
Absolutely. And yet, it's not a single payload on here where you just inject it into its orbit, boom, mission is done. The second stage is deploying several payloads. And like we were talking about before with orbital tugs, the second stage can't burn to get each payload into its individual orbit. And that's where the space tugs come in. They're sort of like an upper stage that'll sort of move a handful of spacecraft around to their specific orbits as needed. And it's very cool to see multiple of them on today's mission. And also on that note, I want to say if anyone has a question regarding this mission, the payloads on board, SpaceX Falcon 9, hit us up in the chat. This is a conversational live stream. We're not just going to be here talking. We want to hear some of your questions and discuss them with you. And starting off with I guess a returning question, what are the 4 towers? So Nick, what are these 4 towers we're looking at? What are they for?
Well, those are actually the solid rocket boosters.
What?
No. Nothing that exciting, unfortunately. That is a common question around here. And those 4 towers are part of the lightning deterrent system. They suspend cables around the rocket to keep it nice and safe in the not totally unlikely, but infrequent event of thunderstorms and lightning while the vehicle is out there on the pad. So those will not be moving today. Unfortunately, it's the smaller, darker stick in the middle that will be flying away. And can we mention exactly how sooty this booster is? Alex, do we know how many times this booster's flown?
Yeah, it has flown already 7 times. It actually flew on the last transporter mission, so this guy already knows, about transporter missions.
Basically an expert.
Yeah, it flew on the last transporter mission, and also, let me look a little bit to my list here.
And this is booster
Q1 and
1061?
Q2. Yeah, B1061. I knew the number booster. I don't know all of the missions because it's so many nowadays, and also there's so many boosters, so I don't have them all in my head. There's some people that do. I know a few of them. But yeah, so looking here, I'm remembering that now. Crew 1, Crew 2, SXM8, CRS-23, XP, which I think that was the coolest mission that this booster did. Sorry for the crew missions, but sometimes it's science missions with me. And yeah, the transporter mission, the last one that it did, and now it's returning back for an 8th mission, which makes it the 5th booster in the fleet, or better said, on the whole fleet, on all the boosters that SpaceX has built and flown, it's the 5th booster overall that has been able to have an opportunity to fly 8 times.
That is very cool. And yet, like you said, they're bringing these boosters up in terms of how many flights they've gotten. I think the highest we've gotten is 12 flights on one booster? Is that correct?
I don't know.
Hold on.
That's a lot.
I would
yeah, I believe we've had 11 or 12 flights on one booster as the highest mission. But again,
yeah, we have had 3 boosters with 12 missions. Yeah.
Wow.
Yeah,
And
I was
again,
looking here at the back channel, and we have a new T0 actually, I think, from the ComsNet.
Ooh.
Gotcha.
Yeah. Seems like they're tracking 3:35, is it?
2:35 p.m.
2:35 yeah.
UTC. Yep.
Yep, so we are about
was off by 1 hour.
40 minutes away.
Indeed. Yeah, so we have our clock now ticking back to T0.
Cool. So great that we're back on track here. SpaceX, like we said, are taking extra time to deal with some thermal management, some thermal testing of the payload deployer. But again, we're back on track. Everything looks to be going good for a T0 in about just under 39 minutes right now. And a question here from Flawed Perspective, going back to something we actually just talked about. Can you describe a space tug in more detail? So Alex or Nick, do any of you want to take this? Like, what does a space tug do? Why is it important? Why are there space tugs on this mission?
Yeah, absolutely. So a lot of these payloads on transporter missions or rideshare missions are actually small CubeSats. And so these little satellite payloads are anywhere from the size of a toaster to a small refrigerator in size. And they don't have a lot of space or mass to be able to provide their own propellants or, kind of attitude control. And so what will happen is they'll kind of bunch up together because they're going to be launching, 59 payloads. And if they launch them all from the exact same orbit, they'd just kind of all be following each other in the exact same orbital plane and the exact same speed. But if they attach a few of them, bunch them all up together in the different groups that are going to similar destinations, then they can more efficiently make use of weight and mass and get those payloads into their target orbit.
Awesome. And yeah, one of the space tugs on board is actually the Sherpa AC from Spaceflight Incorporated. Now, Sherpa is be carrying 5 payloads total today. 3 of those are going to be CubeSats. It'll be separating in the coming days or weeks or exactly when they want to get them deployed, honestly. There's no major rush. But it also have 2 hosted payloads on board, which are basically experiments or instruments that are bolted onto the side of the space tug. And so the tug, like Nick said, will be able to move itself around. It'll have it has guidance on board. It has flight computers. It has RCS maneuvering thrusters. So these are basically small upper stages in themselves to get payloads exactly where they need to be. And also, like he said, it's good because you can spread them out. You'll have less of a risk of any of them hitting each other, which, as we know, things hitting each other in orbit is not that great of a time. So cool that we have 3 space tugs on board today. Now we want to go over some of the payloads. I saw a question in chat, someone asking some specific payloads. I'll start off here. One of my favorite, or one of the most exciting ones to me on board, is NASA Ames Laboratories Pathfinder Technology Demonstrator 3 spacecraft. Now, this is a small CubeSat. Like Nick said, there's CubeSats on board, and it has the terabyte infrared delivery system. And that's a lot of big words, but what that basically means, this CubeSat will have laser communications. It will communicate with the ground not through radio wave, but with a laser. And that's very cool because that is a up-and-coming technology which can give much higher data rates, much fast. It can get data back to the ground much faster. So fast, in fact, that this spacecraft will have a 200 gigabit per second data transfer rate, which is breakneck speed. You will
Wow.
never find an internet connection that fast. So
Can we get that in Boca?
oh my god, yeah. Put like 10,000 cameras down there with that.
Yeah, we get a ton of cameras going on.
I still can't get over that, but that's really cool. Yeah, there's a lot of these transporter missions are great because they give cheap flight opportunities, which really allows say agencies like NASA or companies to put prototype and early design experiments on board, and these can be revolutionary. Like I said, this laser data transmission system can get crazy amounts of data down fast, but you don't want to launch a multi-million-dollar spacecraft on board, say, a $60 million ride to space. With the transporter missions, it's only a few $1,000,000 or only a few $1,000,000 to get a ride up to space on here. So it can be a real good money saver for these agencies and these companies. So again, a great example of just the value that you can get from these transporter missions. And also on board, we have spacecraft from the MIT Lincoln Laboratory, the Missile Defense Agency, and those will be flying on board the Sherpa AC spacecraft. So there's a lot of spacecraft on board, and again, because there's so many spacecraft, there's some we don't even know about on here. There's some spacecraft that we'll find out about maybe days in the coming days or weeks, and some that we might never find out about. But again, a lot of spacecraft on board today.
Can I shout out 2 of my favorite payloads here before we get on to more questions?
Go ahead.
So there are 2 of my favorite. Here are the NanoRacks. They are sending up their Outpost Demonstration 1 mission, and that is actually them testing cutting steel on orbit. Cutting metal is obviously a very sparky experience most times, and so they are using a new setup that involves kind of equivalent to friction stir welding. and that allows them to not have as many pieces flying all over the place. So that's a big test there. And then the second best payload, I think, is selfie sat. I don't know about you guys, but I've always wanted to have my picture taken from space. And so the selfie sat is actually a small CubeSat from Norway that is going to be allowing people to upload pictures and then have a picture. Have their picture displayed on a LCD screen on orbit, and then have a picture taken of the picture on orbit, which is just totally amazing.
That's pretty cool. I like that. And yeah, metal cutting, because we're getting a lot more to becoming a spacefaring civilization. And how can you live and work in space if you don't know how to cut material in space? That's a very basic and very, fundamental part of building anything. So being able to demonstrate a new technology to cut something without creating tons of debris is going to be hopefully a revolution. And we have a tweet from SpaceX now saying, confirming the T0 of 2:35 p.m. They want to do some pre-flight checkouts, including thermal testing on the payload deploy sequence, and that the weather continues to look good. And let's actually dive into a little bit on how they're actually able to hold, because ECR off 20, or maybe EC ROF 25, saying, why can this launch hold but not other launches? Alex, do you want to take that? So why is this launch able to hold, but say a crew mission or a cargo mission, why can't they hold, but this one can?
Yes. So one of the reasons they can actually hold this mission is because they actually have a window. This is not an instantaneous launch window. They have, I think it was 59. I can actually look it up, but I think it was 59 minutes long and 57 57-minute long. And this is actually driven by the orbital mechanics. It's not much related with anything else, but once they start loading the propellants, they have to commit to a T0. That means they basically have only one chance to launch. And that is because of the nature of the propellants that they load into the rocket, which are subcooled. That means they are loaded even cooler than room temperature. So, well, at least for the RP1, the liquid oxygen is loaded at lower temperature than boiling point. And so that basically means that if you run if you stop the countdown and you let the propellants warm up, you lose performance of the rocket, right? And it could also lead to a whole other sort of set of issues and things like that on the properties of the liquid oxygen, for example, or the RP1 and all of that. And so they try to avoid, when they have a hold in a countdown, obviously they try to have it before the load propellants whenever they have these launches where they actually have a window and it's not instantaneous, right? And so why is it not the same for ISS missions, for example? Well, that's because they have to aim for the orbital plane of the ISS. And so that means it needs to be at an instant in the day, which is precisely when the plane of the orbit crosses the launch site. And speaking of fueling, by the way, about 5 minutes ago, fueling was already started. That's basically when they initiate the automated countdown sequence. All the ground computers start, the procedure to load the RP1 and the liquid oxygen on the first stage and the RP1 on the second stage. And I don't think I've left anything else in my explanation. If anyone has any other questions, you have to chat and tag us and see if you need any more explanation.
Thanks, Alex. That was a great explanation. Yeah, like Alex said, if you have any questions regarding Falcon 9, the payloads on board, how Falcon works, SpaceX, space, this launch pad, tag us in chat at NASASpaceflight, and we'll go through some of your questions. We still have 30 minutes here till launch, so we have room for a lot of questions. But before we get into some questions, I want to go through some super chats here. So big thanks to everyone for supporting us through super chats. They really help us to make live streams like this possible. First off, we have Musical Wolves asking a question here. How often does SpaceX plan on having rideshare brooms? And will NSF plan on using a rideshare to get a view of lunar Starship test landings? I like that idea. Let's get a camera on the moon. Moon cam.
Yeah, I think we'll have to talk with DOS about that one. But last I heard, anything we can stick a camera on, we'll stick a camera on it.
All right.
What?
Felt the sad moment.
Within reason. Hold on. What are you signing me for, Nick?
Did I just summon DOS? Wow.
We'll have to
DOS is
send
always
DOS in the
around,
pickup
Nick.
truck to the moon to work on the camera. But that's actually the first question. There's actually pretty interesting. So, Alex, you might know this. How often does SpaceX have these rideshare brooms or rideshare missions?
Yeah, so right now, actually, forgot to say on when I explained the transporter missions, their small excuse me, their small satellite rideshare program actually includes rideshares on Starlink missions. So not only they have these regular schedule missions, but they also have the opportunity to launch, especially if you don't mind going to the Starlink orbit, you can also have your satellite on Starlink missions. And so these transporter missions right now, this year, are being scheduled about every 3 months or so, more or less, month up and down, basically. And so you have January Transporter-3, Transporter-4 was in April. Now we have this one. It was supposed to be in June, but it was actually brought back a little bit to late May. So we are now May 25th. And the next one should be around October, which will be Transporter-6. I'm not sure how it'll be next year, but it's looking sort of the same way. 3-4 missions, and each one of them being every 3-4 months, more or less. So yeah.
Cool. And yeah, that's actually quite a lot because, again, if you think about it, you have 60 payloads in this flight. You had 30, 40 some on the last flight. That's several hundred payloads or several hundred satellites being launched per year on these missions. That's crazy cadence right there.
Mm-hmm.
And actually diving for the next super chat from Westy the Third, saying, no question, just a thanks for all the awesome continued coverage. Thank you, Westy. We appreciate your support. It means a lot. And Musical Wolves, what is the fifth tower? That shorter one in the center. What is that?
I think if we watch that for another 26 minutes and 30 seconds, we might see the fifth tower do something kind of cool.
Yeah, I think that tower is only there temporary, and they kind of just like throw it up in the air when they're done with it.
Mm-hmm.
So
that makes
yeah,
sense.
should be pretty cool to watch that. That'll be neat to see. But thanks, Musical Wolves. And from B here, 10 euros, just saying a quick thank you to the team. Appreciate that, B. Thank you.
Oh, thanks.
And from Jens here with, I'm not quite sure what this means. Alex Head and Beginning Operation Fund, but what exactly does that mean? I'm a bit confused here.
I think or they are mentioning that because I said that I don't actually know all the boosters and all the missions for every booster, because there are so many of them, so many missions and so many boosters and so many flights. So I think that's why. But hey, I'm all for learning that. It's just too hard, and I don't have a lot of time, to be honest.
Our frail little human minds can only absorb so much information.
Yeah.
What a shame. But thank you, Jen, for the support. And James here with an interesting suggestion. NSF shuttle plushie when. Don't say the shuttle word or you'll summon one of the Chris's, but
don't say that.
If you look in the mirror and say shuttle 3 times, Crispy pops up behind you and says a shuttle fact.
Yep, that is true. I do that every morning as I'm brushing my teeth.
And again here from James with the $2 saying, #DOS fan club. We need more narrated videos from him. And yeah, I agree. That was a great video from DOS. If anyone missed it, our new McGregor live cameras, live streaming SpaceX's engine testing down in McGregor, Texas. DOS made a quick recap video on some Raptor testing and some Raptor explosions that we saw recently, and why those explosions are not that big of a that big of a problem. So go check out that video on our channel from a few days ago. Great watch, in my opinion. But thank you to everyone for your support and for all this.
Video was sponsored.
But yeah, we're back here with beautiful launches of Slick 40. Now, Nick, what exactly is this launch vehicle going to be doing in terms of a trajectory? Is this flying east, north? Where are we going today?
I believe this one is southbound, right? With a nice little dogleg maneuver and an RTLS landing.
Yeah, this one's flying on the Polar Launch Corridor.
That is probably one of the cooler corridors we've seen of recent time. Having it thread between Florida and I think part of Cuba and a bunch of little places down there. They thread just right between all of them. But because of that, they kind of have to fly an inefficient trajectory. They have to do what's called a dogleg maneuver, where they go up in one direction, and then once they clear the landmass in one direction, they turn in a different direction. And that is an effective way to make good use of your launch pad at the expense of mass to orbit or performance out of the rocket. And so SpaceX has worked with the FAA and all the proper bodies to get this launch corridor approved and in use, and so they use it whenever they need to do a polar launch from Florida. Which, if I recall correctly, before SpaceX started doing that, I believe last year, it hadn't been done since the '60s. So that was it's kind of a unique thing with them. But yeah, so that's the trajectory this time.
Yeah, great explanation, Nick. Thank you very much for that. And yeah, like you said, we're going on a southbound trajectory, but because, directly south of Cape Canaveral is this small town. I don't know if anyone's ever heard of it, called Miami Beach. It's a really small place. Most people have never been there, never heard of it. But you want to kind of avoid flying directly over a populated area because, say, if something goes wrong with the rocket, say the engines shut off or other bad things happen, you don't want debris from that falling onto a populated area because you don't want to hurt people. So this vehicle is actually going to sort of fly right around Miami, kind of hugging the coast as it goes along, flying almost directly south. And it'll be flying to a sun-synchronous orbit to deploy all these payloads. And what sun-synchronous means, it essentially allows you to get the same view. Let's see. It's kind of a complicated term. It allows you to get the same angle of sunlight on an area every time of day. And I believe it uses the sun's gravity to kind of tug you into that orbit. Is that right?
I don't know about that.
It's a really, really complex ballet of orbital mechanics that makes a sun-synchronous orbit work.
Yeah, if there's one thing I'm not very confident with, it's my basic orbital mechanics. I know just about enough to pretend that I don't know what I'm doing.
It's precisely the fact that the Earth is not perfectly spherical, and so the bulge of the equator just basically tugs your orbit in such a way that you always have the same the plane of the orbit basically rotates around the North Pole the same rate that it basically rotates 1 degree more or less per day. And so at the end of the year, it's like 360 degrees in 360 days, more or less, right? So it turns a whole, yeah, it's a little bit weird to explain. We might actually have to make a video about this.
It's about the shadows, y'all.
Yeah.
Like, you put something in a sun-synchronous orbit because the shadows look the same every day. So if you're doing like imaging or something like that, you don't get a bunch of changes from the shadows being long or short or in this direction or that direction. You fly over the target area at the same time every day, so the illumination angle from the sun is the same. Was my understanding of it, I think, right?
Yeah.
Yeah.
Cool.
All right, I'm not here. Bye.
All good. And actually, we're coming up about 25 seconds on T-minus 20 minutes. Oh, and
there it is.
Right as I talk about it.
Wow.
So what we're seeing right there is the famous big T-minus 20-minute event. Now, that right there is a great indication that we are on track to launch in 20 minutes. That is basically getting rid of excess liquid oxygen inside the transporter erector. Now, when this vehicle launches, you don't want to have fuel anywhere near where the rocket is because, propellants are flammable. And you don't want to have flammable things inside your very delicate launch tower that you want to be able to use in the next few days or weeks to launch another payload. So they're getting rid of excess liquid oxygen in there to make it safer for launch. And that is a great indication that everything is going to plan right there. So a beautiful shot there of the T-minus 20-minute vent. And look how powerful that is. That's not a little vent coming out of the launch vehicle. That is a powerful vent out of the transporter right there.
That sure is. Beautiful, beautiful vent.
Very cool. And moving on to another question. We're actually, this mission is an RTLS, or Return to Launch Site mission. So that means that the first stage is coming back to land at Landing Zone 1. So what are the factors that go into deciding if a mission's RTLS or not? Alex, do you want to kind of go into that? What do they look at to determine if a mission can land back at the launch site, if it can land back at the drone ship, if they have to expend a booster? What kind of factors are they looking into there?
Well, Well, the main two factors that they look at is obviously the payload mass of the rocket, whether it's launching 6, 7, 8, 9 tons, and also the kind of performance needed for the rocket to achieve the mission that it wants. So, for example, in this mission, it's going, I think it is about a 500-kilometer orbit, and it's going first into an elliptical orbit, and then it's doing a synchronization orbit once it reaches apogee at the other side of the Earth. And so that kind of performance then drives, the taking into account the sort of performance that you want and the orbit that you want to reach with the rocket and the payload that you're carrying, the mass that you're carrying and everything. You put that together and you're like, okay, this doesn't let me go back to land, right? And so then you need to deploy the drone ship. But if it actually lets you to return to the launch site because it's basically light enough and the orbit it might be low enough, that then allows you to go back to land with a booster. And that's about it. Like, there's not a whole lot of other constraints. In this mission in particular, there's an extra bit there where the performance of the rocket diminishes because of the dogleg maneuver. Some of the energy and performance of the rocket goes into actually turning the rocket away, from land and then moving it into the desired orbital plane. And so it's a little bit complicated to actually say it with hard numbers, but it seems like to this kind of orbit they might be able to launch about 6 to 7 tons. And other missions obviously have different like other orbits have different constraints and things like that, but generally about 6 to 7 tons might be sort of the limit here that we're looking at.
Cool. Very cool. And thanks for the insight there, Alex. And yeah, this mission is landing at LZ1, which I saw a question in chat asking where it is. It is about a few miles south of Space Launch Complex 40. So with the camera we're looking at right now, if we went to the right a few miles, we would get to landing zone 1. And it looks like we've had the T-minus 20-minute vent has stopped, or at least significantly slowed down. There's still a little bit of venting happening there. Again, that's all to be expected. And we are getting this beautiful footage here, I should add, from our friends in the field, Thomas Berghart, Julia Bergeron, and Stephen Marr. So very cool to have all of them out there. And I believe we have Julia on comms now, do we?
Why, yes, you do. I am here.
Oh, looks like Julia's cutting out a little bit, but great to have you here, Julia. I didn't even realize you were on comms with us. But again, beautiful. Looks like we are on track here, just over 15 minutes from liftoff of Transporter-5. Now we'll hop back into some super chats, actually, because we had another queue build up while we were answering some questions there. And Boris here saying, do you believe in belters? People, interesting question. I don't feel like I really understand what this person is, what Boris is talking about here. People which live in 0G. Do any of you have an idea what this is talking about?
No, I don't.
Not at all.
The only thing I know about belters is loud and forceful singers. So I don't know.
And I mean, we do have people living in 0G right now on the International Space Station, so I guess I do believe in that. But thanks for the support, though, Boris. We appreciate that. And also, Rough Riders Show, actually with a question I was thinking the other day. So with the next Falcon Heavy launch, the Psyche launch, which will be launching a NASA probe to a metal asteroid, which is pretty cool, they had a short window to launch. What's the latest they have to launch it? That's a good question. So originally their launch window was from August 6th to, I think, the 26th of this year. But with they recently extended it back to August 1st, so it seems like the launch window is a bit larger than what they've been than what they had expected. As well as Falcon Heavy will be expending its center core on this mission. They won't be recovering the center core, so that may give them a little bit extra performance to work with here to give them a longer launch window. But the principal investigator, basically the person who's in charge of the mission, said on Twitter that they're still actively working on how long the launch window can be. So it seems like it's a very fluid situation and they're trying to work on it best they can. But interesting question there, and I hope to find out the answer to that soon as well. And James here again He'll say, "DOS not wearing a hat and a suit is still giving him nightmares." That's
Oh
mean.
my.
But yeah, it is interesting not seeing DOS with a hat. But thanks for the support, James.
Yeah, I don't know if I've ever seen DOS without a hat on. And
It's not really that bad. Come
We've
on.
worked for
Yeah,
months
no, it's
together.
not bad.
It was a little shocking.
DOS is
Wait
a
a minute,
great-looking
DOS. Where's
fella.
your hat?
But thanks for the support, James. We appreciate that. And Space Shuttle Discovery, calling me out directly, saying they did not give me permission to own a piece of the shuttle. I do have a piece of payload bay liner from the Shuttle Discovery on my wall. So, might be in trouble there, but
Ooh.
and I
You
will
know
try
what
to
I
convince.
have?
Ooh, what do you got?
Well, you know what I have? I have a piece of STS-135 external tank foam.
Ooh, I have a piece of that as well. That is very cool to have.
Yeah,
was
that
the
was a
last one,
special
right?
one. Yes, it was, and Atlantis
Wow.
is my baby.
Aw.
Wow.
So, Julia, you're a Team Atlantis for your favorite space shuttle?
Yes, sir.
Cool. All right. Well, I may not agree
I
with you,
mean,
but I
I do get to
respectfully.
visit her, and well, yeah, I mean, I do get to visit her. She is very pretty to look at, so.
I will agree with that one. But thanks for the question there, Space Shuttle Discovery. And Tim C, $20 super chat saying 20-minute event. A little late on that one for me reading it, but I appreciate that, Tim. Very cool. And also, Ryan here, good point. It's been too long since we got to see a good RTLS landing. Let's see how that robot tracks a landing. And that's a good point. I'm excited to see because we've been talking about how Michael is working on autonomous tracking software on the robots. So it would be very cool to see how we've seen before that it can track a rocket going up, but can it track a rocket going down? That is the big question. That'll be cool to see, though, but I'm excited to see another RTLS as well, Ryan.
I'll say, to be fair to the West Coast people, we had an RTLS less than like a month or so ago from Vandenberg. So it's actually not been that long. It's been that long from Florida.
I guess you're right, Alex. All right, let's argue pedantics.
See, if Jack were to be here, apart from being very furious about this being a polar launch from Florida, he will say, "Hey, we had one from Vandenberg." But yeah, it's true. It was also in the fog, so I guess it kind of doesn't count because it
It
was
doesn't
not
count if you can't see it.
Yeah.
Very cool. And let's hop back into another question. Michael here, speaking of RTLSs, will there be any Falcon Heavy night launches with an RTLS? And we've already had one, right? STP-2, the third launch of Falcon Heavy, was a nighttime RTLS. That was interesting to see. Now, it's a bit too early to figure out whether any upcoming launches will be a return to launch site at night. The exact timing is kind of released, say, at best, maybe a few weeks or a few months in advance. But yeah, we'll have to see in the near future what happens. I know Psyche was tracking for an afternoon launch, but then it was delayed a month and a half. So we'll have to play that one by ear and see what happens. But thanks for the question. And a question here. Nick actually might be good for this one. Any news on the FAA decision? So the Starship decision for FAA, have we heard anything about that? Just a quick little question here.
Well, we haven't heard anything other than May 31st is the current goal of them being able to release the final report there. So believe you me, everyone down here, and I'm sure lots of people at home are sitting on pins and needles waiting on that decision. So we're all sitting here waiting for the decision.
Absolutely, me too. And that's going to be very exciting to see what happens there, but hopefully it does come in the coming days. But again, you got to be careful and take your time. But and before we get back into questions, I would like to thank Brilliant for sponsoring this live stream. Brilliant is an online interactive learning platform that allows you to learn at your own pace through interactive material. And interactive learning has been proven to be the best way to learn. Now, Brilliant doesn't just make you read through paragraphs and paragraphs of information. They guide you through topics with examples, diagrams, and simple little questions along the way. And one lesson I've been working on recently is gravitational physics. And I like this lesson because they take an interesting approach to it. It guides you through a sort of short story to help explain the material to you. And with each lesson, there are several small questions along the way. And one of my favorite parts of Brilliant is that if you get a question wrong, there is a detailed explanation available on how to get the answer and how you could have gotten to other incorrect answers. So Brilliant is available to start for free, but the first 200 users who use our code NASASpaceflight get 20% off an annual premium subscription. And you can see Das there doing a little explanation of the course there. So Brilliant has a lot of courses available in science, technology, mechanics, mathematics. There's a wide variety of courses available for anyone, any level of experience, and any topic that you're interested in. So check out Brilliant. You can start for free. And if you like Brilliant so much, you can get 20% off an annual premium subscription using the code NASASpaceflight. So thanks again to Brilliant for sponsoring this live stream. And hopping back to questions. We have a question from Tommy here. We actually discussed this a little bit before, but Alex, give us a quick answer to this. Does super chilling the fuel allow you to extract more energy from it? So what happens here? What is the benefit of condensed and densified propellants?
Well, the main reason to do super chilling on the fuel is because it makes it more denser, so you can pack more of it in the same volume. But a side benefit, it's actually because you can actually flow more of it through the engine, so it gets you a little bit more of thrust. So it's double-sided, although that secondary side effect is not like really huge, not as huge as the actual packing of more propellant into the tanks. But it still helps. It's nice to have.
Absolutely. And speaking of chilled propellants, coming up at 7 minutes here, so about 14 seconds away, Falcon 9 is going to begin doing engine chill. So what that means, they're going to run some of the liquid oxygen through the engines to get them ready for launch, because you don't want to immediately start flowing that through and then immediately have a very hot combustion come through. That is a great way to destroy your engine. So they're going to slowly trickle some liquid oxygen through the engines to get them chilled down, get them ready for flight. And that is happening at T-minus 7 minutes there. So we're coming up towards the end of our countdown, but we're still going to go through a few questions here. And from Nick Lewis here, not Nick Sweeney, from another Nick Lewis, saying, why do all polar launches go south? Can you go north out of Florida? And I can actually take this. Oh, actually, Nick, you want to go ahead with that one?
Okay, yeah. So the window that you have to fly, because right, you don't want to fly a rocket over anybody's house because rockets go boom sometimes. And you want to make sure you're clear of any ground obstacles. And if you pull out a map and you look at Florida, Florida is really far east, but if you go straight north, directly north for a northern polar orbit, you will notice that there's quite a bit of the Carolinas and most of the eastern seaboard right north of you. And so they want to make sure that they're not overflying anything during critical phases of flight. And so that's why they fly south. And it really doesn't matter if you go north or south from an orbital standpoint, because as Das was explaining, you'll still have the shadows at the exact same position every day at any time of day. I believe that there are no northern polar launch complexes in the U.S. They're all southern.
Interesting. And I believe you're right. I don't think there are any northern launch complex, because from California, if you fly north from Vandenberg, you fly California.
I guess
fly north.
Kwajalein might be able to fly north, but I'm.
Yeah, I think they actually launched north, or no, they were launching south, because we had SpaceX launching also from there way back in the Falcon 1 days. And I'm trying to remember, but I think they did south from there too. Yeah.
Very cool.
Well, there you go.
And just passing T-minus 5 minutes there. Looks like everything is still on track for a liftoff in, as I said, T-minus 5 minutes. So we're going to go through a few more questions, and we're going to talk a bit more specifically about what we can expect to see later in this launch. Now, for anyone joining us, we are giving you live footage of the Transporter-5 launch. This is a rideshare mission on SpaceX's Falcon 9, lifting off from Space Launch Complex 40 at Cape Canaveral Space Force Station. And this mission, a rideshare, is basically a collection of small satellites that are launching together on one big rocket. Think of it sort of like riding a bus. A bus is expensive, but if you have a lot of passengers on board that can split the cost, then it becomes very cheap per person. So this is a great way for some small companies or agencies to launch their small satellites at a very nice discount price compared to getting a direct launch. And we have 59 payloads on board today. So it'll be very cool to see this liftoff in just over 4 minutes. And
Wonderful.
what was that, Nick?
No, it's just so wonderful looking at the rocket just right before it takes off. It's alive with all the vents and the just looks so alive sitting there, ready to go.
It feels like the calm before the storm, because it's just gently venting with the wind, carefully, gently bringing all the vents away. But it's about to get very hectic here in just over 3.5 minutes. Very cool. And Missed Solar with an interesting question. Have there been any CubeSats that re-entered the atmosphere and were recovered in good shape? I don't think so, because when a satellite re-enters the atmosphere, nothing really comes back.
A lot of them are actually designed not to have anything come back, so you want anything to dissipate in re-entry.
Yeah, exactly. The Starlink satellites are a good example of that because they're specifically designed because there's so many up there. If one of them re-enters, you don't want any debris hitting the ground because it could hit someone's house, it could hit a person. You don't want any damage from that. So it's designed to completely burn up as it enters the atmosphere. So there's just not really going to be much coming back from any of these CubeSats if they re-enter the atmosphere. And 2 back-to-back questions here real quick. Crash 664x4 saying, what are our thoughts on Psyche getting delayed? So the next Falcon Heavy launch was set for August 1st, but has now been pushed back to September 20th, and that is the launch of NASA's Psyche probe. Personally, kind of sad because I wanted to go to Florida in August and see that, but now it's scheduled for when school is in session, so I can't really go and see that now. But what can you do, That's the price of
field trip.
Exactly. Yeah. Oh, a field trip. I lost my professors. But thanks for the question, Crash. Very cool. And we're coming up at just over 2 minutes here. Now, let's go over some of the events that we're going to be seeing as we get closer and closer to T0. So coming up here in just under a minute at T-1 minute, we'll be seeing the flight computers take control of the countdown. Now, up until this point, the flight controllers in mission control have had a little bit of control over the vehicle. They can abort, they can stop if they don't like something. But at this point, after T-1, the flight is entirely in a computer's hands. If something goes wrong, the computer will stop the countdown. So we'll see that at T-1. Also at T-1 minute, we're going to see the propellant tanks pressurized to flight levels. So they'll become pressurized to become stiff enough to survive flight. The Falcon 9's propellant tanks are not strong enough to support themselves while unpressurized, so they pressurize themselves in order to get some additional structural rigidity. Then coming up at T-minus 45 seconds right after that, we'll hear a go for launch from the SpaceX launch director. That is the final go for launch. If that is good, we are launching today unless the computer doesn't like something. And coming up just over T-minus 1 minute, Falcon 9 should be getting ready for flight now. And passing T-minus 1 minute. Now we're seeing here the vents on the vehicle. You can see all that gaseous oxygen from about halfway up on the rocket. That is just any remaining gases being vented out of the vehicle, the transporter erector. We'll see those begin to shut down as we get closer to T-minus 1 minute as well. And all looking good here on the transporter mission.
And we have go for launch.
And we've had go for launch. Excellent. So the vehicles are now ready to go. Unless the flight computer finds something wrong, we are launching today. So it will be very exciting to see. I'm really excited to see an RTLS landing. This is going to be so fun. I can't wait to see what footage we get here. And T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have engine ignition and liftoff of Falcon 9 carrying 59 payloads to low Earth orbit as part of the Transporter-5 rideshare mission. And the vehicles cleared the towers, and look at those beautiful shots that we have right there. Now we are a few miles away from the liftoff, so we're not hearing any sound just yet, and there's a sound.
Oh, wow.
Wow, look at that.
Oh, that's
stunning shots
beautiful.
here today.
Beautiful look. That was a great look at, I forget what that's called, a condensation cloud as the vehicle's going supersonic.
Yeah, that was amazing.
And T plus 1 minute and 12 seconds, the vehicle is now going through the maximum aerodynamic pressure, which is when the atmosphere is pressing the most force on the vehicle as it pushes upward.
And impact engine chill. Now the second stage main engine is getting ready to fire in just about a minute or so. Actually less. Scratch that. This is not like Starlink. Starlink is a little bit longer time.
And we've gotten so used. Oh, look, we got some more shots of the rocket through the clouds. Beautiful. And you can notice that as the rocket is getting higher and higher, the contrail, or the engine exhaust, is getting a lot wider. Now that's because the vehicle is getting higher and higher in the atmosphere, and because there's a lot less gas pressure to push in on the exhaust, it's spreading out more and more. Very interesting phenomenon to watch as we get further along in the launch. Now coming up in about... Yep, as I was saying, in about 10 seconds, we're going to be seeing main engine cutoff, where the 9 Merlin engines on the first stage will shut down, followed then by stage separation and second stage ignition.
I was actually about to point out that you can see the MVAC engine chill on that camera.
And
yeah,
we
you can
have
see
main
like
engine cutoff.
vapors. There we go.
Stage separation confirmed.
Very nice.
You can see this, the first stage like flipping back.
Yep. And beautiful shots of the second stage there. Now, the next milestone will be fairing deployment in just about a minute from now. But the first stage is boosting back to Cape Canaveral. It's firing its engines backwards, so it has flipped itself around, and it is firing to slow itself down, return itself back to Cape Canaveral for landing. Meanwhile, the second stage is continuing south and is slowly doglegging its way around Florida to avoid overflying any populated areas. But all looks good so far in the Transporter-5 mission.
Some people might notice now on the telemetry, we get a lot of questions usually about this, that the speed doesn't go all the way to 0. And some people are like, but why? It's going back to land, right? Well, what goes to 0 is the horizontal speed, but the booster is actually going up. You can see there that it's now 125, 126. So you still have a component of that speed of it going up. And we have had now shutdown of the booster boost back burn.
Awesome. And while we have a moment, or actually we're coming up on fairing separation in a few seconds. Also now the payload fairing, which is encapsulating all the satellites, protecting them from the aerodynamics of Earth's atmosphere, is going to separate and expose them to the vacuum of space. And looks like we've had a good fairing separation there. Now, Alex, what is going to happen to those fairings? Are they throwing those away, or what exactly is going to happen to those?
Of course not. This is a SpaceX. They're coming back down for reuse. And so the way that they do that is they use RCS thrusters on the fairings to reorient for reentry. And they actually use them sort of like surfing through the atmosphere. They use the big round surface that they have. And they are very lightweight. They are composite structures. So they are lightweight. And actually, they slow down very gently and very nicely compared to even the booster because of that. And so they just need to orient them in the right position, and they sort of like surf back down to the Earth. And once they are low enough and slow enough, and slow and low, they deploy the parachute and just gently splash down in the ocean to be recovered by either of the fairing recovery vessels. I actually don't know for this one. I wasn't paying too much attention this week to the fleet, so sorry, Gav, if you're watching us. Yeah, it happens sometimes. But I think it might be either Bob or Doug. They have like this and see. Yep. Oh, Julia. She's gonna answer that. Bob. Okay, Bob. Yeah.
Bob is now waiting
between here.
Bob is now waiting right in between Cuba and the Bahamas to go fish for some fairings.
Nice. Yeah, we have 3 experts here. We have our fleet expert, Julia. We have our Falcon 9 expert, Alex, and our Starship photography expert, Nick, over here. So we got a very loaded live stream here. Y'all are very lucky to have them.
And I have a quick question here. Did we just watch the 100th Falcon 9 Block 5 launch happen?
I believe it was
Yes,
the
we
100th
did.
launch, the 99th reflight, and the 20th reflight of a booster in 2020, and the 122nd booster landing, assuming this is going to be a good landing here, and also the 48th consecutive landing, and it will be a record.
Wow, look at Nick with all
Pretty
the
cool.
specs there. Very
He
cool.
has all the stuff that I usually have on my lists and everything.
Well, I did my homework, Alex.
He did his homework.
Wow, teacher's pet. Yeah, very cool. This is the 100th flight of Falcon 9 Block 5, which is the most recent and also the last version of Falcon 9 that SpaceX will develop. After Block 5, they're moving on to developing Starship, as we're seeing down in Boca Chica, which Nick is excellent at photographing, may I add.
Can I say how beautiful these landing views are? Like, we're seeing now about to see the re-entry burn, and like you can see all the coast of Cape Canaveral. Oh, hey!
There's the entry
Look
burn.
what we have here.
Beautiful. Very quick entry burn. So what did we just see there? What was the entry burn? What is that all about? Nick, do you want to go over why they have an entry burn?
The entry burn is here to make sure that you bleed off as much energy as you can while you're just approaching the thickest part of the Earth's atmosphere, and also using a little bit of the exhaust as a cushion as you're re-entering the atmosphere here. And I'm sorry, there's a bird sitting right next to me.
We're getting some natural sounds here. Oh, and look at that.
Oh, wow, look at that.
Tracking shot of the booster coming back down. Oh, and looks like we lost it for now, but we still got plenty of time to catch it. We're about a minute away from landing right now. Now this vehicle will be landing back at landing zone 1. Is that correct, Alex?
Indeed. Now it seems to be approaching.
Oh, and
hey,
there it is.
There, the landing burn.
We got the booster. Now we have booster 1061 coming back to land at landing zone 1. Beautiful shot of that single engine there burning to slow the vehicle down. Now landing burns with Block 5 have always been single engine, I believe. Oh.
Ooh.
Wow.
We have views from the beach.
Interesting shot. That's a new one.
Yeah, it seems like it's landed.
And looks like we've had a successful landing. Beautiful return to launch site landing. Those are a little uncommon nowadays, but very cool to see another successful landing. And also at the same time, we should be coming up on second stage engine cutoff. And looks like we've actually had that. But a great, looks like a successful liftoff today from Cape Canaveral of Falcon 9 on the Transporter-5 mission. We had a beautiful landing, a beautiful liftoff. And it looks like we've had a successful insertion into a transfer orbit. Now, the second stage will be reigniting about 50 minutes from now, where we'll see the second stage reignite for just a few seconds to get it into a slightly higher orbit, where it will begin deploying its payloads. But also kind of happening right now, we have the experiment that Nick was actually talking about before. So we have the Outpost Mars demo experiment, where they'll be demonstrating cutting metal. That is happening right as we speak on board Falcon 9, so very cool to be hearing that. And again, we have some beautiful views of the beach here. Very cool shot here that I don't think I've ever seen that before. We've never seen that before, have we?
We haven't put a camera there before. For an RTLS. Yeah, that's new.
Cool. Very cool to see that. And a beautiful view of the launch pad after a successful liftoff. Now the transporter erector there is about 45 degrees backwards. They throw it backwards right at liftoff to keep it out of the way, and to keep it clear of the rocket as it lifts off.
Yep. And actually, the view from the beach is actually telling you that we have this so much commonplace right now. I remember very early when Falcon 9s were to come back, the beaches will get there was many people lined up just to watch this. I'm not really sure if there are a lot of people right there because the view is very narrow. but I don't see a lot of them, and not a lot of them were looking at the rocket. So it's been very commonplace for them, it seems. Yeah.
Very neat. And now, first off, we want to give a shout out to our merch. If you would like any cool NASA spaceflight themed merch, any cool Starship, Boca Chica themed merch, we have anything that you could ask for, even some Boeing OFT-2 merch coming up here. So if you would like to purchase some to help fund our operations here, check out our store at nasaspaceflight.com/shop. Some beautiful merchandise that we have there, some shirts, towels, anything you could ask for, we have it there. We also want to go through some of our super chats. Thanks to everyone for the support there. James Juries saying, oh, and a shot there of our merch store.
You mentioned OFT2, and I must point out, Starliner has undocked from the ISS, by the way.
Yes.
So it's about to land later today, I think in about 4 hours, right? Somewhere around that.
I believe so.
Yeah.
Yep, it'll be landing about 6:30 p.m. Eastern, I believe. And there we go, a beautiful shot of our boost back broom shirt, going off an old joke of Falcon 9 being America's broomstick. Very nice little play on words there.
I think somebody actually has that shirt on right now. Let me see if we can't get a shot of it. Stand by.
Uh-oh, now I'm interested to see what we got here. What's Doss got up his sleeve?
I know Mary was wearing that today, so.
Very cool, repping the merch out in the wild there at Boca Chica. And again, there a look back at a successful Space Launch Complex 40 after a successful liftoff. The transporter erector is reclined about 45 degrees from vertical. Now, coming up next, Alex, right, they're going to bring the transporter vertical in the coming days, bring it back to the hangar, and then get it ready for the next mission. Is that right?
Yep, the next mission which you'll expect from here is actually a geostationary communications satellite. And a rare thing these days, which will be a expanded booster. The booster is going to be expanded for that mission. So yeah, that's
Wow.
gonna be a rare one. But we're gonna be here for it, and we're gonna live stream that. So keep an eye out for that one.
That was very cool. Thank you for the information, Alex.
Yeah.
And while we wait on that picture of someone wearing our broomstick shirt, we're going to go into our super chats. So thank you for everyone for the support. We really appreciate it. The super chats make live streams like this possible. This equipment is not cheap. These cameras, this software, none of this comes cheap. So we really appreciate for all your support here. So from James here saying, are y'all looking forward to For All Mankind Season 3? I have not. Oh, and there.
Oh, yeah,
there's
there we
Julia.
go. RTLS.
Turn around and wave, Julia. This is Julia wearing the RTLS shirt.
Just wait.
A wild Julia spotting. Very nice, but that is one of our shirts that you could pick up at the NASA Spaceflight shop. So head on over today and grab yourself some merch. But like we said, For All Mankind Season 3, I haven't watched the show past Season 1. Any of you guys watch it?
I have not.
Oh, I have watched
the
first two seasons. And yeah, I'm really looking forward to Season 3.
Gotcha. Very cool. Hopefully they do well with that. And then for Moldy Space Industries, #tracking fan club, we appreciate that. Mark W. saying RTLS for their birthday. Thanks, SpaceX. Happy birthday, Mark. I hope you're having a good one. And what
Happy
a great birthday present.
Before they start screaming.
The best candle.
Very true. Best candle, the biggest candle.
Okay.
And Crafty Geek here, following up on a question we had before, talking about belters from the Expanse. Okay, so people who spend their lives in zero-G environments with interesting physical characteristics. Okay, that's interesting. I'm sure we'll have those coming up in the next few decades, so that'll be very cool to see the effects on the human body from extended weightlessness. But thank you for support, Crafty Geek. We appreciate the context there. And Boris here, again, Boris also expanding on their question, saying Belters is a race from the Expanse. Is it possible from our point of view to live and have children in zero-G? That's an interesting question. I mean, I don't think we really know that yet. The only way to find out is, I guess, to run experiments, honestly. Anyone have any insight?
I have no idea, but I'm of the same thinking. The only way to find out is to actually go ahead and do that.
And last but not least, we have from James here another $5 super chat. Speaking of northern launches, isn't his state Michigan supposed to get a spaceport soon? We've heard about a Michigan spaceport. It's been thrown around. I don't know if there's any concrete information on what's going to be happening there, but it seems like the idea has been thrown around for a spaceport up in Michigan to launch over the Great Lakes. I don't know the exact status on that. I don't know any of you guys know anything about that.
I don't have any information about that. I only know that, yeah, they were wanting to do that, but not sure how it is going right now.
Yeah,
so I want to point out in chat, people are like, as the sonic boom basically expands all the way through Florida, they're saying, hey, now we're here in Orlando, and in here, and in there, you know? So it's amazing to see that on chat.
That's so cool. On a side note, I've never thought about that. The sonic boom doesn't just happen there; it travels across the state. That's so interesting.
Yeah.
I never thought about that.
Takes
It's
a little
cool.
bit of time.
Yeah, thanks everyone in chat for sharing your information on that. That's really cool. I didn't know that the sonic boom could be heard that far, but very cool. But yeah, so thank you very much. Oh, and also we've had a new member here, Krupex79. Thank you for becoming a PadRat member. And our memberships are a great way to support what we do. We have a large membership program, and your membership helps us to fund streams like this. Like I said before, all of this stuff is kind of pricey, so it really helps to have support from you guys from that. So thank you to all our members for their support. But on that note, I think that brings us to the end of our launch live stream here. So I want to thank, first off, all of you guys for watching, everyone for their super chats, their memberships, all their support throughout the stream, but also to my co-host, to Alex. Thank you for being here, Alex.
Oh, thank you for having me. It was super great to see a booster landing back on land.
It was very fun. And also, Nick and Sweeney are Boca Chica, one of our 2 Boca Chica Starship photographers. Thank you for showing up as well.
Absolutely. Me and Hoppy are very glad that the Transporter-5 went well, and I'll go back to taking pictures of Hoppy now. Thanks for having me.
Starbase.
Are you out at the launch site right now?
I am at our highway plot right now, so I bet you if you guys tune into Starbase Live and you look at one of our cameras, I bet you I'm standing right next to one of the ones you're looking at.
Very cool. So Nick is out there in the field right now. We have some on-the-site commentary here coming from Nick. But thank you, Alex and Nick, for showing up, as well as everyone out in the field. Julia, I don't know if we still have you, but thank you for coming out, Julia.
And thank you for having both Thomas and I. It was a blast, shall we say, and it was a wonderful boom as well.
Absolutely. Yeah, Julia, Thomas, and Stephen out there today. So thank you to everyone, all my coworkers report. Thank you for everyone for watching. We just saw a successful Transporter-5 launch from Cape Canaveral through SpaceX. Thank you everyone for tuning in. Have a great rest of your day.
Liftoff. Propulsion continues to be normal.
Chamber pressure looks good. Doubling up. Roger, roll, Atlantis.
Water towers can fly!
Tango Delta nominal.
Flight outside SCE off. Bring in SCE off.
Yikes. You bet. Concur. We don't need any more of these.